Now let us learn about the display devices. First, let us consider the LEDs. Light emitting diodes or LED is an output device for visual indication in any mechatronic system. It is used as an indicator for status of various signals or situations, like say for example power conditions, device on, battery low, charging of battery, etc. What is an LED? LED is a simple PN junction diode and it contains an anode and a cathode terminal. For the functioning of the LED, anode should be connected to the positive terminal of the supply voltage and cathode to the negative terminal of the supply voltage. We should see to that there is no maximum current flowing through the LED as it would get damaged. Hence, usually a resistor is used in series between the power supply and the LED to limit the current flow through the LED. LEDs can be interfaced to port pins of processors or controllers in two ways. Either the anode is connected directly to the port pin, so whenever the port pin is at logic high, the LED will glow, or else the cathode will be connected to port pin and anode to the power supply. So when the port pin is in logic low, the LED will glow. In the first case, the brightness can be varied as per the requirement, whereas in the second case, getting a brightness of the requirement as per the requirement is not possible. Let us take an example. Write a program to flash the LEDs connected to port 1 of 8051 microcontroller. Let us assume that the anodes of the LEDs are connected to the port pins. Thereby, when the port pins are having logic high, the LEDs will glow, and when the port pins are having logic 0, the LEDs will be turned off. ORG 8000H, we are indicating through the assembler directive where exactly the code is placed. Move A, FFH, move P1, A. So you are sending logic high to port P1 and the LEDs will be glowing now. We would like to visualize it, therefore we'll call a small delay. Then move A, 00H, move P1, A. Again you are making logic low to all the pins, therefore the LEDs will be turned off, call a delay. And we have to flash it continuously, therefore SJump back to repeat. The next display device is the 7-segment LED display. It is an output device for displaying alphanumeric characters. It will have 8 LED segments arranged in a special form. Out of the 8 LED segments, 7 are used for displaying alphanumeric characters and the 8th one is used for displaying decimal point. These LEDs are named from A to G and the decimal point sometimes is called as DP. Sometimes we also refer it to it as H. So if you would like to display something on this, then these LEDs should be enabled. It is available in two different configurations, common anode and common cathode. Let us see what are these configurations. In the common anode configuration, all the anodes of 8 segments are connected commonly, whereas in common cathode, all the cathodes are connected in a common fashion. So in a common anode, if you want any segment to glow, then that particular segment cathode should be connected to ground. Whereas in common cathode, if you want any segment to glow, then the anode of that particular LED has to be a logic high has to be given to that particular anode. Based on the configuration of the 7-segment LED unit, the 7-segment anode or cathode will be connected to the port pins of the processor or the controller in such a way that the segment A will be connected to the least significant port pin and the segment DP will be connected to the most significant port pin. So like your normal LEDs, even over here, we shouldn't allow maximum current to flow through, and hence a limiting resistor will be connected always. Let us take an example now. A switch S1 is connected to P1.2. A common cathode 7-segment display is connected to port 2 of 8051 controller. Write a program to check the status of switch and display appropriately on the display. That is, when the switch is on, we need to display the character 1 on the 7-segment display, and when the switch is off, you need to display 0 on the 7-segment display. So we need to monitor the switch S1 continuously. Now we will assume that switch S1 is connected in such a way that one of the pin of S1 is connected to the port pin and the other pin is connected to power supply or to VCC of 5 volts. Let us program P1 as input port first. So P1, #0FFH. We need to monitor P1.2 continuously. So jump on no bit P1.2 to L1. So jump on no bit, the switch is not pressed, therefore it is in off state. Since it is in off state, we have to display 0. Therefore, at L1, we have to write a code for displaying 0. So the hexa equivalent for displaying 0 on the 7 segment display is 3FH. Move A, #3FH. Move P2, A. Load it into P2 and just jump back to loop. So again I have to monitor P1.2. If there is a bit, that is if there is a bit at P1.2, that means the switch is being pressed and we have to display 1. So move A, #06H. 06H is the hexa equivalent for the character 1. Send it out through port P2 and again I have to monitor, so let's jump back to loop. Next display device is LCD. It is a display device used to display alphanumeric characters. So here is the table which gives the pin description of LCD. You have 14 pins. Pin number 1 is ground, pin number 2 is power supply, pin number 3 is used to controlling the contrast of the LCD, pin number 4 corresponds to register select pin. So it is an input pin. So when RS is equal to 0, we are using command register. When RS is equal to 1, you are selecting the data register. Read write pin is again an input pin. So if you send a 0, you are writing to the LCD. If you are giving a 1, then you are reading from the LCD. Whenever you are sending some data to the LCD, you have to enable it. So enable pin is an IO pin and then you have 8-bit data bus. We have to write commands for the LCD when we are initializing it. That is, we have to instruct it where exactly the cursor should be, whether the LCD should be, whether the display should be on, whether the cursor should blink, how the cursor should shift, whether right side or left side, whether we want to display it in the first line or whether we want to display it in the second line. So these are the different hexa codes for the LCD and these codes differ from one manufacturer to a other manufacturer. So how do we write to an LCD? Before we display anything, it has to be initialized. So you can store all the command words as an array and store the message or the data to be displayed again as an array. How do you initialize the LCD? Select the register first so that it behaves as command register. You are writing, so make read bar write as 0. Give a low to high pulse to the enable pin. So give a high to low pulse to the enable pin. So make E is equal to 1, give a delay and then make it low. Similarly for writing data, only difference is you have to make the register select as 1 so that you select the data register. Let us take an example. Write a program to display MMC cores on the LCD connected to 8051 microcontroller. Note the following, that is, we have some pin connections over here. Port P1.1 corresponds to enable pin, P1.2 corresponds to register select pin, P1.3 corresponds to read bar write pin, and port 2 corresponds to data pins of the LCD. So first, as I said, you have to store all the command words and you have to store the message what you would like to display. So I am storing it in at the location 9800H. These are the different commands and this is the message which I would like to display. Let us get into the main program. Move dptr, # command. So this address will be loaded into dptr and since I have to repeat all this for every commands, let me use a subroutine. So acall L1. In L1, this will be a code memory. This is written in the code memory. So let us take move C A, at A plus dptr. And I have to check whether I reach the end of the commands. Therefore, I am terminating it with a 0 and I am checking over here. If it is a 0, then jump on 0 to exit, return back to the main code. If not, increment the pointer to point to the next command. Move p1, 00h. So when you send 00h to port p1, you are making the register select as 0. Thereby you are programming, you are considering the command register. Load the data into port 2. Then give move p1, #01h, where you have given write signal is being given and enable signal a high is being given. Have to give a high to low pulse on the enable. So we have to give a high to low signal for the enable pin. So move p1, #01h, call a delay, and then again clear it. S jump to L1. So this will be continuously executed till you reach 0 over here. Once 0 is reached, return. It will come to the main code. Now similarly move dptr, #message, a call L2. Now we have understood this routine. The same routine I will be repeating, only with a small correction that instead of the command register, I will be taking the data register over here. So move p1, #04h, which corresponds to the data register. Similarly to your commands, the message one by one character will be sent and it will be sent out through port P2 with the enable signal being given and the write signal being given. And this is the delay routine.